Yeah, like this, I think, and this one is oil rate. So this is for the original objective function of oil rate mismatch, and I don't want to use this. So rather than using the available objective functions, I want to add my own. So click on add here, and let's call it objective O function underscore history matching HM. All right. So here, this is my own objective function. Okay, so this is actually a new parameter. And let's set this objective function. I want to focus on first, yeah, history matching quadratic. And I want to use the objective type, or the object type is field. And the parameter is, as I said, oil total. But not only oil total, I will combine this oil total with water total field, and let's use water total. That the weight 1 and 1 each. Okay, so this is my new parameter. I call it objective function history matching. It will combine the oil total and water total. The difference, yeah, the difference of oil total and the water total. The difference between the results from each run to the actual value. Okay, so let's go back to table and let's squeeze this one. And here, let's find objective functions. You see, we have 1, 3 objective functions. Open that tree and let's find our new parameter, objective function history matching. Okay, and currently in this table, we don't have this parameter. So let's click on this one. So we have objective function history matching. This is our parameter of main interest. So let's move that parameter here. Click on this one and move it up. Okay. Where is it? I can't see you. Are there? Yeah, you can also move it horizontally, but it's rather slow. So let's move it vertically instead, like this. So yep, I put it here. So I have the model, the objective function, oil total, and water total. So I'm just going to focus on the objective function because it's already considered all the oil total as well as the water total. So let's sort here. So you see, interestingly, the closest run that will give me the closest value, the closest mismatch value, considering oil total and water total, is this one, run 2, and then run 20. Okay. So if you want to check, let's go to the graph here. Okay. And yep, let's expand the experiment here. And let's untick this one. And let's see. This is the case, the base case. I want to see, not this one. Okay. And not 0, 0, but 0, 2. Okay. So based on water total, I think it's quite good. Let's compare it with the second rank. I think it's 10. Let's check the graph. Okay, so okay. So 2 is better than 10. 2, of course, is better than 9. Oh, actually, 8 is better, relatively speaking, for water total. Okay, so 8 is a contender. 7 not good. 6 quite good. 5 not. 4 not. 3 no. 1 no. Okay. So let's consider about oil total. So for oil total, interestingly, 8 is good. Okay, so let's untick everything. Let's see. 8 is very good. Water total is also very good. Okay, and let's check the table. But the objective function is not good. So let's tick everything. So where is the run 8? So for oil total, sorry, oil total, run 8 is quite close. For the water total, run 8 is also close, very close. But for objective function, okay, so let me go back to my objective function. Maybe we made something wrong. Oil total and water total, okay. History matching, quadratic, okay. And okay, so yeah, this is something that's quite interesting. So yeah, let me show you. Let's go back, untick everything. We are currently looking at oil total, and actually we have the two base case, 8 and 16. All right. You can also maximize if you want to know. And let's see if we can change the color, or maybe later. So this is for 16. So 16 is better than 8 for oil. And for water, let's check 8 and let's check 16. Okay, so these two are the best. But if you take everything first, if you go to table somehow and you just like this, set this OFHM like this, somehow the rank of 8 is at the bottom, and 16 is also not good. Okay, but let's see if you use oil total, 8 is good, 16 is good, close to historical values. And also for the water, 8 and 16 are the closest runs to the historical values. So that's why you need to be careful if you use objective function. So let's review our objective function, and rather than using deviation type relative, I'm going to use absolute. So if you use absolute values, you cannot run away. Okay, you will get those two as the best. So let's try. Go back to table and sort the objective function, and there you go. You get 16, the first rank, and 8, the second rank. Okay, so I'm going to use this 16 and 8 as the best. So be careful if you use relative for the deviation, this thing can happen. But if you use absolute, just by the word, it's absolute, then it's absolute. If you're the best, then you're the best. Okay, in oil or in water or in both. Okay, so that's for table and histogram.